Hello, guys. Welcome to part 1, 2, 3, 4. So this is part 4. We're gonna continue on yesterday's lecture. We're gonna talk about the storage options. So yesterday we have said that we have 4 storage options. We have EBS, Instance Store, EFS, and S3 bucket. Today we're gonna cover block storage, which is these two: EBS, Elastic Block Storage, and Instance Store. And then tomorrow we're gonna cover FSX and EFS. So EFS and FSX. Here's it, and FSX. So we're gonna cover these tomorrow, and as we have an independent 2 days for it because it's a really big topic. Okay. So one thing we have understand using EBS and Instance Store that they are block storage. So here we can see that. Let me add a subheading, and we can see that block storage equals hard drives. So hard drives can be SSD or HDDs. Okay, so this is really important to understand that hard drives are block storage in cloud, and hard drives can be either SSD or HDD. So in EBS, we have actually a few types of EBS storage, and they either can be SSDs or HDDs, and we're gonna check these out right now. Okay, so why do we need block storage? When we say block storage, because we have this thing called input-output. So let me put this up here. Let me add another subheading. So another subheading, and we can say that hard drives gives us something that's called input-output. So this is input-output. And another thing that's called a throughput. So these kind of terminologies, we use them when we're talking about hard drives, RAMs, when we're talking about the difference between CPUs and RAMs and hard disks. So yeah. Input-output, which is I/O, and throughput, these are things. So throughput, I think it's more related to file storage, and input-output are related to hard drives. And we're gonna see that Instance Store right here have very high input-output, and EBS have lower but kind of good input-output results. So let's check these out. So first thing we're gonna talk about is Instance Store. So basically, Instance Store have a lot of features. So the first feature we're gonna talk about is a temporary block storage or block level storage. So we have to make sure that it is a temporary thing. So when we say that Instance Store, I'm giving a few notes. Instance Store equals temporary block storage. Let me get that right here. Okay, so when we say Instance Store, it's a temporary. Let me put. I really want to like highlight this. So it's the temporary block storage. Why do we use it if it's temporary? Because it has a higher input-output than higher I/O than EBS. Okay. So this storage is physically attached to our virtual machine or the computer that is running the instance. So this is physically attached. And then we're going to talk a few more things about how is it temporary, what's the definition of a temporary storage. We're going to understand the difference, and we're going to talk about everything. So the first thing we're going to talk about that it is what is called ephemeral. So ephemeral means temporary, or when something shuts down, it's gone. Like, if you want to like, you can see that Instance Store is kind of like RAM. So RAM, kind of. So let me say kind of. Okay, so basic computer 101. So let me put that here. I want to write like something fancy. Okay, this is fancy. So if you want to say basic, I want one. Thank you for two. But let's say here basic computing. That's huge, but that's fine. Let me make it a little bit like 40. Yeah, that's good. So basic computing 101 says that, please ungroup. I want to remove this. Okay. So basic computing 101 says that RAM is, there's two stuff. So we have RAM and ROM, as we know. So I need another text box. Let me just copy this and I'll have this as my. So basic computing 101, we have this a thing called RAM or ROM. Let's start with ROM, and second thing that's called RAM. Okay, so random access memory and random, I forgot what the O is. Let me, so ROM, RM, random only memory, yes. I was gonna say only, but it felt wrong, but that's fine. Okay, so ROM is used basically for booting stuff. Why am I writing in the caps locks? That's fine. So ROM is basically used for booting, starting up a machine, or like an operating system in general. So this cannot be shut down. So let's say can't be removed when you're shutting down the computer. So basically, yeah, if we're turning off our computer, of course Windows is not gonna go away. So this is what works on ROM. RAM is different. So RAM is random access memory. This is also ephemeral. So the word ephemeral. And this everything is lost when you shut down your machine. Okay. So an example of RAM we can give, like when you're copying something. So if I tried copying this, so I copied, and then I want to like refresh or restart my machine or turn it off and then turn it up, we can know that we're not going to have the thing we copied anymore. So this is going to be on our RAM memory. So if we copy anything and then we restart the computer, it will be gone from the clipboard. Okay, so this is basic computing 101. So let me put 101. So yeah, ROM, which is, I haven't tried what ROM means. So here is random only memory, is used for booting, for operating system, and it cannot be removed when you're shutting down, when you are, so you are shutting down the computer. But RAM, which is the random access memory, it's ephemeral, sorry. So if we copy anything, then we restart the computer, it will be gone from the clipboard. So everything is lost when you shut down your machine. So Instance Store is kind of the same. So it's ephemeral. It's attached to our virtual machine. As we can see here, we have, this is an instance, by the way. So this is an instance. As we can see here, you can see this is a database, but I like to consider it as Instance Store because I couldn't find anything with Instance Store, but that's fine. So we can consider this as an instance with an instance store, and then after termination, it's gone. So after when you terminate or anything, it's gonna be gone. Why do we need this if we're gonna temporarily lose our data, or if we're gonna lose our data when we terminate our instance? So either it can be for temporary data storage, like buffers, caches, and scratch data. If we remember, we had in Linux. Where did the I want my text. So draw. I want my text. I can't even find my text. That's fine. Yeah, here it is. Okay, so let me put a sticky note. Okay, so we can say that in Linux, we store, let's say, temporary logs or anything like this, or caches, buffers. We store it in the /tmp path. So instance stores are kind of the same. We have a very high input-output performance. It's suitable for application that requires low latency storage. So let's check input-output of instance store of AWS. Here we can see that instance store is temporary block storage, as we can see here. Let's check out the limits. I want, okay, I think there is an instance store. Not the SSTs. Data persistence, it's gonna be gone. Yeah. Okay, so basically, if I remember, let me ask ChatGPT. So let's say, what's the maximum input output for instance store? What is the maximum? What is the maximum input output for instance store in AWS in comparison with EBS? So let's check this out. Man, I want numbers. Give me numbers. So give me, oh, sorry. I don't want to be rude to him. So give me numbers. Okay, so here we can see that the maximum IOPS, which is input output performance, is around 2 million. And the maximum IOPS for EBS, look at the difference. I can't imagine. So here's the summary. Let's take the summary and let's discuss it. Okay. So let's go down a little bit and let's put a subheading and then paste the thing we have discovered. So can you check out the difference between the two? Okay. I can't hear my voice. Yes. No, Muhammad, I can't hear your voice. Uh, but you can hear my voice. So yeah, I think Muhammad have left, yeah. Okay. So as we can see here that instance stores can have up to 2 million IOPS, which is input output performance, and we have up to 46,000 megabytes per second throughput. So you can see the difference. This is one of the most, we have EBS types. We're gonna talk about them. So IO2 is the best type of EBS. These are used for the heaviest workloads. So these have up to 6,000 IOPS and 4,000 megabytes of throughput. So you can see the difference right here in the numbers. So let me put that in here. Good. And we have said it is ephemeral, so after termination, it is gone. We need to understand this right here. Okay, so the limitations, we've said that it has a side limitation, so it's limited by the type of the instance, and we have said we have 5 types. We have more than 5 types, but we have discussed about 5 types, which is general purpose, storage memory, and compute optimized, and accelerated computing. And also it's not persistent, so data is lost when the instance is stopped or terminated, or if the underlying disks fail. So it's not persistent, it's ephemeral, as we said. Okay, so this is for instance store. Let's talk about EBS. So EBS is a persistent block storage. So here's the difference. Persistent, non-persistent. Instance store is not persistent. Block storage is persistent. It's not ephemeral. So this is a block storage volume to use with Amazon EC2 instance. So this is used with EC2 instance because it's on the AZ level, of course. And EBS volume are automatically replicated within their availability zone. So you can see here within their availability zone. So you can understand that the EBS is AZ, the scope of EBS storage. So let me write down here. I need something that is new. I need something that says coming soon. I'm joking. Yeah, I want something that's yellow. Okay, don't forget to subscribe, guys. I'm joking. Yeah, so let's say that EBS is AZ level. So that's the scope of EBS. So EBS is a level. So we can also talk about that it is redundantly replicated along its availability zone, and it offers high availability and durability. Of course, it depends on the type. So some types have less durability and some types have more durable and high availability, and we're gonna see these. So let's talk about a few stuff. So snapshots, we have these are the key features. So we have something that's called a snapshot, which is this right here. This is the snapshot, which is, as you can see, a bucket and something like right behind. And we can use them for boot volumes. So boots, as we said, what is a boot? Is literally when you're trying to get out uh, and the last thing you do before getting out is wearing your boots or your shoes. So this is the boot instance. It's what makes your machine up and running. So yeah, so best practices, the regular snapshots, we're gonna encrypt our snapshots and performance monitoring. So let's talk a little bit about snapshots and volumes and what is incremental backup. So incremental, again, we need to understand what means. We need something new. I don't know, I'm just feeling good today, so I'm gonna hello, how are you? So incremental, incremental backups, or just incremental. I don't need backups. So incremental, and then EBS. So here's how are you? EBS. Okay, so EBS is incremental. What does this mean? So basically, this means if we have, let me have this, let me have this pencil. So if we have this, and we took like a screenshot of it, so we have this is the original, which is O, and then we took, let me change its color. Let me make it a green color. That's good. So I took a snapshot from it and put it in my EBS. So this is a snapshot S1. So if I want to add something here, and I want to take a snapshot out of it, so this is O1, and I want to take a snapshot of this, I just can't take a snapshot of what are we adding. So this is called an incremental backup. So if I want to add another thing, so if I want to add another, let me choose a color. I want to choose orange. Good orange, yeah. So if I said I want to add O2 and I want to take a screenshot out of it, so I'm gonna have this incremental kind of backup. So yeah. Actually, this is not how it's done. So let me show you basically how it's done. So if I want to take a screenshot out of the first one, it's gonna be like this. It's gonna be the same drawing, but in an increment type of way. So this is S2, and then we're gonna have the third one, which is S3, and this is gonna have our O1. And here I'm going to insert O1. And then we're going to have our O2. So let me O2. So this is incremental incremental storage. Yeah. This is what I mean by incremental storage, guys. Okay. Let me give you a moment to read and like figure things out because I talk very fast. Okay. And I'm sorry for the bad drawing. I am an artist actually, but not in a computer way. So you see this drawing right here beside me or behind me, I have drawn this. And also this one, I have drawn this. And there's one above my head. So I am an artist, but not in the computer way. Okay. So let me remove these and let's get to it. So we said snapshots are kind of an incremental backup stuff, and these are stored in an incremental way. So as we can see here with the bad drawing, all this kind of stuff. Let me do this. Okay. So why do we use snapshots? We use them for persistent storage. So even if our virtual machine shuts down, why am I doing a virtual machine? I have it right here. So even if our virtual machine shuts down, and this is our snapshot. So let me put our snapshot right here. So even if it's terminated, it's gonna be the same. Even after termination, we're gonna have the same. It's different than the instance store one. So after termination, we're not gonna have any kind of in the instance store level, we're gonna have a new hard drive, but in the ABS, we're gonna have the same hard drive right here. Okay. Boot volumes, we have told like if you want anything to run, we can use it in the boot volume. So guys, we have 1, 2, 3, 5, 6 types of EBS volume types. So if we go on AWS docs, which is the best place I get references from, so we can here see that we have SSD drives, as we said at the first, and HDD drives. So if we went back to Computing 101, where's Computing 101? So before Computing 101, here we have said that hard drives can be either SSDs or HDDs. So if we went here, we're gonna see that we have hard disk drives that are HDDs, or we can have solid state drives, which is SSDs. So here we can see we have 4 types. We have GP3 and GP2, IO1 and IO2, and here we have ST1 and SC1. We're gonna talk about it. I have put them in table. So as we said, 4 are SSDs and 2 are HDDs. So as we can see here, this is the SSD part. So SSD, 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 SSD. We have GP2, GP3, IO1, IO2. These differ in cost. These differ in durability. These differ actually in like everything. So general purpose SSD is more expensive than the newer version. So you can see your GPT-3 is less expensive than GPT-2, as we can see here. So lower cost with consistent baseline performance. And we have both of them have the durability of 99.39%, and they both have up to 16,000 IOPS. So internet input-output performance. So GP3 is kind of used for general purpose workloads, and GP2 is used for small to medium-sized databases, dev or test, and system boot volumes. So, okay, so these two are basically one group, so GP2 and GP3. We have IO1 and IO2. Those are more expensive, as we can see here. IO1, which is up to 64 IOPS, which is the same as IO2, but the difference between these are in durability. So as we can see here, there's an additional line right here, but this like gives us a really big difference. So if we go and ask ChatGPT, we're gonna see and tell him to explain the difference between these two percents. So we're gonna check these out. So what is the difference between 99.39% durability and 99.49% durability? I have wrote it wrong. That's fine. Okay, you can see here that the difference is between, okay, I do one. So it's the possibility of data loss over a given time. So known as 5 nines, which means you have the percentage of 3 nines, right? 5 nines, which is, yeah, 5 nines. So it means we have the loss of 0.30 per year. And you have to expect a loss of one object out of 100,000 objects per year. So, and this 6 nines is kind of different. So as you can see here, this is 1 out of 100,000. This is 1 out of 1,000,000 objects per year. So here we can see the difference between the two. It's not really a big difference if you're like me, you're just a person, but it's a very huge difference for companies. So as you can see here, this is called enterprise application or large databases, and this is also for large databases and critical applications. So this is higher durability. As we said, there is an extra 9, and this is designed for input-output intensive applications that provides high performance with low latency. So let me give you a moment to read the table. Let it load. Okay. So here we can see we have two types. We have SSDs and HDDs, and SSDs are 4 types. GP2 and GP3 are a family. IO1 and IO2 are another family. You can see the difference in cost. IO1 and IO2 are very expensive. GPT is the cheaper option, and GP2 is the medium option. It's like in between. Okay. So we have the HDD options, which is lower cost than SSDs. These are more old, let's say, not old, but I don't know what to call it. Like you can see the difference in the output, input, and I/O. You can see here that this is up to 16,000. This is 500 to 250. Like there is a huge difference. So this is a low-cost HDD, and the lowest of them is SC1, which is the cold HDD. So this is designed for less frequently accessed workloads, so infrequent access data or backups. Both have the same durability. This has the half of the first one. So low-cost HDDs designed for frequently accessed intensive data. So this is used for big data, data warehouse, or log processing. So not something that's very critical. I'm gonna give you a moment to read this, like 1 minute. And we can see that there is a huge difference between the two. This is like, it's called cold, so it's for archival stuff, let's say. Archive, yeah. Okay, so notes. I have a few notes. So you can only use GP2 and GP3 and IO1 and IO2 as boot volumes. So the SSD EBS are used for boot volumes. We can't use HDDs as boot volumes. So only in IO1 and IO2 we can multi-attach. So as we said, that EBS volume is, let's go down. Let me remove these. Okay, so here we can see that only EBS is an instance level thing. So if we want to say like, let me draw AZ, that's it. So the only one option to have like multiple AZs, like AZ2, and then we're gonna have another instance. Let me upload. So if you want to like multi-attach an instance, we can do that using only IO1 and IO2. So there is this thing in exam. So multi-attach. IO1, IO2. So this is an IO1 and IO2. That's it. So there is a topic in the solutions architect part and even in the developer exam that's talking about EBS multi-attach. Okay, so you can create encrypted volumes. So encrypted as something you can't, as we've seen like in previous lectures, how we can see that the keys. So here you can see they use keys such as AES 256. So this is an algorithm. I think it's a asymmetric algorithm. So AES 256 encryption. Yeah. So it's a symmetric, yeah, sorry, not asymmetric. It's a symmetric algorithm. And if you take snapshots from encrypted volumes or encrypted snapshots, it's gonna be encrypted. So if we have an encrypted volume, so let's say, let me see what I have uploaded. So let's say, oops, sorry. So this is encrypted. Let me put it in red. So this is encrypted. So if I try to take any kind of another snapshot, it's also gonna be encrypted. So let me just copy and paste it. So if we want to copy anything, so let me just go up and say copy. If we want to copy out of encrypted, it's gonna be encrypted. It's gonna be the same. And they use keys, as we said, this is a symmetric, it's a symmetric key. Okay. So best practices, as we said, we can use encryption for sensitive data. We can regular snapshots. We can like schedule regular snapshots for backup and data protection. And we can perform monitoring using CloudWatch or any kind of performance service we need. So we have actually finished. So this is going to be for tomorrow, EFS. But we're going to talk about a few stuff in our EC2 console. So let's do that. Okay, so as we can see here that if we went down, we can see the dashboard, the instances, the images, the block storage. So we can see here lifecycle manager, snapshots and volumes, and these as well. These two have another lecture to its own. So if we want to create an instance, let me use the user data thing I used. Let me go up. Here it is. Let me copy this one. Only this. Okay, so now if we want to launch an instance, we can see that we can click here on launch instance, which is roughly really easy. So my server, and then we're gonna choose Amazon Linux, instance type T2 micro. We have talked about this earlier, and then proceed without a key pair. And we're gonna allow HTTP because we're downloading Apache. So here we can see that we're configuring storage, we're using GPT-3, and we have these options. So these type of volumes are not boot volumes, as we can see here. So we have talked about this. So we can increase or decrease the gigabytes we need. We can add a volume. We can also incorporate a file system that we're going to be talking about tomorrow. So in advanced details, we have talked about user data. It enables us to run scripts while booting. So we have entered the shebang line, which is the bin bash script, and then we're gonna update install Apache, which is HTTPD, or Apache to an Ubuntu Debian based virtual machines, and then we have talked about systemctls, these kind of stuff. So let's launch this kind of instance. Launch, please. Please wait while you launch. Don't close your browser while we're loading. Okay. Okay. So today's lecture is very, very easy and basic. I love it. So let's go now to instance. Let's give it like 2 minutes to load and run. I'm a very patient person. This is what they say. By the way, I have uploaded my slides for anyone who is really curious to know what we're gonna talk about. On my GitHub repository, I have also uploaded ELB, which is Elastic Load Balancer, and Auto-Scaling Group. I have uploaded both. So we can go to the instance, we can see it's running, and we can open the address. It's gonna give us the Apache server, but of course now it's gonna give us that we can't open it, of course, because it's HTTP. Okay, so if we went down here and we went to storage, you can see that we're having this kind of volume. So let's make an image, because yesterday an image didn't create with me. So let's try and create an image today. So go to actions, image and templates, and then we can create image. So enter image name, Apache image. Okay, no reboot. Yeah. So we're gonna leave everything as it is. So create image. And we have successfully created an image, as you can see here. So if we went to an AMI, here it is. So this is Apache image. So now if you want to use or run an instance, we can run it using another, like we can use the same image that we have used. So let's say my server 2. And then we can go to browse more AMIs, Amazon Machine Images. This is for operating system. And if we went to my AMIs, we can see that we have our Apache image. So let's select that. I've my AMIs. Okay, from catalog. Okay, yeah, that's good. So T2 micro, everything is gonna be the same. I want to proceed without the key pair. Allow HTTP. We're gonna select an existing group. So let's select the one we have used. So is it launch wizard 1? And this is the same EBS. It's gonna maybe. Let's launch. Let's check it out and check if it works like this one. Diagnose. Retry failed tasks. Why? Snapshot is invalid state. Okay, let us diagnose it. Let's give it a moment to read. That may resolve. The snapshot is trying to take an action and still in pending state, so we need to give it like a moment. That's fine. Okay, so we can see that the snapshot is still trying to pend. We've go to EC2 actions, and we're like doing it so fast. That's why. So let's go to EBS snapshots. Here we go to snapshots, and I think it's gonna be still pending, which is fine. Okay, complete. It's not encrypted. We can encrypt any kind of instances we have. So if we went here, for actions, we can create a volume and we can create an image, modify permissions. So here it is private. Of course, it should be private. Cancel. I don't want any cut. Yeah, and that's it. So we can create a snapshot. We can create a volume. I want to select the volume, description. So and then description. So I'm gonna call it Apache server, and that's it. So create snapshot. It's really easy to create snapshot. So this is incremental, as you can see. This is really fast. This is incremental, and we have only one volume, which is attached to our as you can see, recently backed up. So yeah, we can take as much snapshots as we need. So here we can see that the description is Apache server, and this is the new one. So I think EBS is really, really easy to use. And these kind of topics are like easy. So I don't know. What do you think? Is it easy? Is it not easy? Is it a bit complicated? Let me go back to yes, EFS. Okay. So today's lecture was very forgiving, not like yesterday's lecture. We have talked about block storage, two types, which is instance storage and EBS. Tomorrow we're going to talk about FSX and EFS, which are file storage. Let me stop the recording.